Hi guys, good afternoon. So today we'll be starting with VPN, but the question remains, what is VPN? Full form? Hmm? IDP. To connect with two private IPs. To connect with two private IPs. Communication. With that also I can do the communication, right? Hmm? Secure. What do you mean by secure? Unauthorized person will not enter connection. Unauthorized person will? How? How unauthorized person will not enter your communication or connection? Hmm? Prepared for interview, right? Hmm? Tunnel. First of all, tell me what is overlay and underlay. Hmm? Above and below. What is an overlay network and what is an underlay network? What are the modules you have completed? Building virtual tunnel to protect data. What is data? What is difference between information and data? Hmm? What is the difference between information and data? We are security people. We must know this. Hmm? Data has every information. And what information has? Hmm? Only for like no. Online only one person, two-person are responding. What about other people? Why not everybody is responding? Passive listeners or active listeners? Hmm? We should have full duplex communication, right? Two-way communication should be there simultaneously, right? We should not have halfway or half duplex. So tell me, VPN very important. Hmm? And we don't know VPN. Haven't we used VPN? Hmm? Nobody has used. Seriously, no. Only you. What about other people? Used? Why you are using VPNs? What kind of network? So, okay, so you say like you will connect to some other country, you will see a location, you will click on the location, and then you will be able to access it. How does it work? Hmm? Security purpose. What security purpose, Bima? For what security purpose you use? And how we can provide security first of all? Hmm? How VPN is providing security? So if we use NAT communication, we will insert the IP in the get the knowledge packet which is transferring. But in the VPN, we will communicate between one office to other office, but the packet generally we create a tunnel. The private traffic will be went from the tunnel only, private community. But still, it will be traveling through the ISP, but the traffic will be encrypted and the various. It's authorization. Authorization. What is authorization? The NAT translation do not have any authorization where to communicate. If we know the IP means we can connect easily. We provide authentication to the network means each two the IPs are the same. Each two routers are the same authentication type. They may communicate. The traffic won't travel by anyone if they know the IP also. If they know the IP also. Or they know what are the server has a domain name and everything they know also they can't connect because they don't have any authorization and passwords. Passwords. Okay, so when you connect to VPN, you have to provide usernames and password, right? Are you sure? Are you sure? No. For the secure community. This is what I'm asking, right? How does it provide security to your communication? So the tunnel is overlay or underlay? Underlay. Guess or sure? Okay, first of all, understand underlay and overlay. Underlay is the network that provides physical connectivity. That provides you physical connectivity. That means your physical infrastructure, routers, switches, cables, whatever you use. That is what? Your underlay network. And overlay is your virtual network that is built on top of your underlay. So VPN is what? Is it something physical? No, right? It's not physical. It's a logical concept. Virtual. GRE is? No. Even GRE is creating a tunnel that is virtual. VPN entire concept is virtual only. Okay, but it works on the underlay. That means on your physical infrastructure. Now, why do you require VPN? Okay, so if I take one cable, let's say, for example, I have two branches, one in Bangalore, another one in Delhi. Okay, and I want to have communication between these two branches. Now, one way is I can have a secure communication. How? I can have my dedicated cable itself from Bangalore to Delhi. How far it is? So far, approx 2,500 kilometers, right? Now, if you will take a cable from, Bangalore to Delhi, how much cable you need approx? 2,500 kilometers of cable. And that much amount of cable is very expensive. Okay, let's say somehow you purchase the cable also. You purchase the cable. Now, how you are planning to take the cable from Bangalore to Delhi? Two possibilities: over the pole, underground, because there is no water. We don't have an ocean in between Bangalore and Delhi, right? So over the pole, not a good idea. Every day it will keep on breaking. Let's say underground. Now, is it possible for you to dig? No, right? So even if you try, you have to hire some company to do it for you, because you will not go yourself taking a something to dig. correct? So you will hire a company now. First of all, you have to pay the company, their daily expenses, the labors and all everything. And let's say they laid the cable in Bangalore. Now they are walking towards Delhi. And as soon as they are out of Bangalore, somebody was digging the road. Your cable is damaged. Even if you laid the cable from Bangalore to Delhi, all over India, we know every day how many people are digging the road. That means your cable has good chances to get broken, to get damaged. Now maintenance is also required, right? So is it possible for a company to have a cable from Bangalore to Delhi? And what if it's just a startup having two branches, one in Bangalore, one in Delhi? Not really possible. Then what option do we have? That means you cannot take a cable from here to Delhi. Now you need something, but you want that, okay, your data should be secure. Your data should be safe. And I asked the question, what is the difference between information and data? Data is the raw form. Data is the raw form. And information is meaningful data. The data that has some value. Hackers are not trying to steal your data. They are trying to steal information. So eventually, with the help of network security and everything, what we are trying to do is we are trying to prevent what? Information. We are trying to protect information. Now your information, in how many forms it can be present? Your information, in how many forms it can be present? Hmm? Hmm. Then you will say image, video, MP3. Yeah? No, zeros and ones, binary. Okay. My question was, in how many forms information can be present? Text, picture, video, physical or digital, two forms. Your data, your information can be present in two forms. Okay. One is physical form, another one is digital form. By using these VPNs and all, what you're trying to protect? Which form? Can I send a physical document through the VPN tunnel? Not possible. That means digital form of information we are trying to protect. And right now, everything is getting digital. That is the problem. So now what? I want to have secure communication between my two branches. Digital information like all your text, picture, video, these are what? Digital information only. Okay. So now you want to have secure communication between Delhi and Bangalore. You cannot have your own cable from Bangalore to Delhi. Now you still need a communication media. You want to communicate. So you'll say, okay, maybe I cannot lay a cable. So let me use a cable that is already present. Somebody has already laid it for you. And who has done it? Who already has a cable from Bangalore to Delhi? Your service providers, your internet service providers. They have connected the entire country, right? Now what we can do, we can say the ISP that, okay, give me one cable in Bangalore, one cable in Delhi. And we should have a dedicated line. There is nobody else's traffic should pass through that particular cable. Now, if I have one cable and from that cable only my traffic is passing, is there any risk? Yes or no? No, because only my data is there, right? So ISP will give me, but ISP will charge me really good, giving me a dedicated cable from Bangalore to Delhi. Why? Imagine you want to travel from Bangalore to Delhi. You will take a flight. but you're telling the airline company that, okay, in this flight only I will go, nobody else should go. In the entire flight, there should be only me, nobody else should be there, because you are so concerned about security. You are so concerned about security. So how good the airline will charge, right? Because there is a capacity of like 180 to 200 passengers, and out of all of them, only you are going. And if one customer was about to pay 10,000 rupees, one passenger was about to pay 10,000 rupees. So imagine 180 passengers, how much they would pay? 1 lakh. Hmm? How much? Hmm? 18 lakh? Santosh says then we can opt for helicopter. Yeah, you can. Even if you try to take a helicopter from Bangalore to Delhi, how expensive it will be. Even this is going to be very expensive solution for you. Hmm? What's the guarantee? But still it is expensive, right? It might be cheaper than you were having your own cable, like you are having your own private jet. Cheaper than that, but still expensive than usual. So what is the option you have now? And even if you take that also, let's say, for example, you have taken one dedicated cable from ISP. Okay, you have taken it. But what is the possibility that hackers will not sniff the information? What is the guarantee that your ISP will not look into the information? Correct? We do not have any guarantee here. Yes. Have a seat. Okay. There is no guarantee, because hackers, they can compromise your network. So even in that situation, we require what? Security is required. Security is required. Okay. Let's say this is also an expensive solution, because first of all, you have to purchase that one dedicated cable from Bangalore to Delhi, and then you have to implement VPN also over that. Correct? But that is costing you a lot. In here, we call that concept, when you purchase a dedicated line from a ISP, we call it lease line. Okay, we call it lease line. Now what? You don't want to pay that much also. You don't want to pay even that much. So what you'll do? Let's say now you are saying your airline company told you that, okay, we will charge you 20 lakh rupees if you want to go from Bangalore to Delhi. Now this is not your budget. What you'll do? You will say, okay, fine, just give me one seat only. I don't want entire plane. I just want one seat. That means you are ready to share this time. This time you are ready to share. Same concept here we have. That means you will tell the ISP, okay, give me one connection here, one connection there, but my traffic should be segregated. Other people's traffic can go through the same cable. I don't worry about that. I don't care about that. But my traffic should be segregated. There should be no interference. There should be no interference. Now, this shared concept, this is your MPLS. This is your MPLS, where shared bandwidth you are getting. Okay, so this will be definitely cheaper than your, like some way you were paying 20 lakh rupees, now you're paying 10,000 rupees. Right? So this is cheaper, but still security is a concern in this case also. So again, here also, what you have to do? You have to use so in real time, VPN between branch and head office is only through lease line. That depends. Okay, it can be through lease line, MPLS, or you can have through internet also, direct internet also. Because your eventual goal is what? To securely communicate. We just want to securely communicate. That is our main goal. Okay. So in that case, what will happen? Again, in a case of MPLS also, you will have VPN for security. Now you'll say that, okay, this is also not a good idea. Why should I pay? Because eventually you're taking an internet connection, right? So I'll take an internet connection in Bangalore branch. I'll take an internet connection in Delhi branch, and everybody is connected through the internet. Now, if I directly send my traffic from Bangalore to Delhi via the internet, huge amount of risk is there. My company's confidential information can be compromised. My company's confidential information can be compromised. Okay. So if I want security there, again, I will do what? VPN. Now, how VPN is providing the security? How your VPN is providing security? Think about it. So when it comes to VPNs, there is a term CIA. CIA. Okay. What your VPN provides. And authorization. These are the three terms. Confidentiality, integrity, and what is the A here? Authority, accountability, anything else? Hmm? Hmm? A is for authentication. A is for authentication. Now tell me, what is confidentiality? Again, what is confidentiality? Sorry? Who has the access? They only can access. They only can access. Okay. And what is integrity? What is the index? The exact data is provided. Again, repeat please. What the data is find it no any alteration. No any alteration. Okay, that means there should be no unauthorized changes in the information while it is traveling from source to destination. Okay, so how do you provide integrity? Ashwin. So how does it work? How your integrity works? Hmm? How does it work? Hmm? Hashing. But how does it work? Because we are saving the same algorithm with the same encryption and encryption. The data what will be encrypted from the key that from the same key the data will be decrypted. Then there will be no changes. Okay. So here you are talking about encryption. And when you talk about integrity, you say hashing. Both are different. Okay. Hashing information is converted through hashing algorithm and produced unreadable code, which is not reversible at receiver end. Hashing is checked to find any changes. See, we have studied about TCP header, right? In TCP header, there is something called as checksum. So how does the checksum works? How does your checksum work? One simple example I'll give you. Okay. How does it work? See, confidentiality is all about, in one line, if I say only authorized users have access to the information. Okay. And this is done with the help of encryption. Okay. And when it comes to integrity, it is, you can say, the guarantee that there are no unauthorized changes to the information while it is in transit. So when the information is in transit or it is at rest also, both are fine. So there should be no unauthorized changes. Authentication means, what is authentication? What is authentication? Verification, how? Username and password. That means verification of the user, whether the user is correct or incorrect, like whether the correct user is accessing or not accessing. So how do you verify? Using some sort of authentication method. Okay. So this is what? Verification of a user. Okay. Now, I was talking about integrity, and your authentication is done with the help of, sorry, integrity has been checked with the help of hashing. Hashes, you guys were attending Linux. Remember shadow file? Those were what? Hashes. Okay. So always remember your encryption is reversible. Okay. Encryption is reversible. That means if something is encrypted, can be decrypted. And hashing is irreversible. Something that is converted into a hash cannot be reverse engineered. Okay. Now, one simple example, if we take, understand here. This is sender, this is receiver. Okay. And these are connected. And connected, let's say, with the help of internet. This is your PC1. This is your PC2. And here we have internet. Okay. Now the sender here wants to send some information. Okay. So let's consider the sender here wants to send the information. Hello. Okay, wants to send a hello message to the PC2. Clear? So what this sender will do, along with this message, it will also include a checksum. It will also include a checksum value. So let's say I'll copy it and let's go and calculate some checksum. I'll put my data here. I'm using here MD5 algorithm. Okay. And I'll say generate. So I'll copy this. Okay. This is the checksum value that has been created for this information. Now what? This guy will include it. This information will be included along with the message. So what will happen? This message will be sent to the receiver. What the receiver will do? Receiver will take up this information, and then receiver will also use the same algorithm to calculate the checksum. Okay, so this is the received checksum. This is the received value. And now receiver will also calculate it. This is the data, calculate it, and then it will verify. Receiver will verify. Are these same or different? Same. These are same. That means the data has not been modified in the transit. This is clear? Okay. Now, second scenario we can consider that this guy is again trying to send the message hello, but this time somewhere there's a hacker. Okay. This time in the network or on the internet, there is some hacker. Okay. So now what will happen? When your sender is sending this information, sender has included the checksum value. The hacker will intercept this message. Once the hacker has intercepted this message, hacker will modify this information. Very small change. Okay, very small change I'm doing here. And now see what will happen. This is the new information. And now forward it to the receiver. Receiver will do what? Receiver will take up this data and calculate the checksum. This time, this is the data. Generate, copy. This is the calculated checksum. Same or different? Different. That means the data has been modified. And we also know data has been modified. So even if there is the slightest change, even if there is the slightest change in the information, every single bit of your hash has 50% probability to change. And you can see very slight change was there. And you can see almost every single bit changed. The entire hash changed. How sender and receiver communicate about this hashing through internet? So see, hashing algorithms, when we will study about VPN, you will know that they will already be establishing what? Security association. They will be establishing what? Security association. So there we will clearly mention that this is the encryption algorithm that will be used. This is the hashing algorithm. All these things will be communicated. Okay. All right. And when it comes to TCP, so how TCP is implemented? TCP is the same protocol that is implemented on both side devices. Okay. On both sides of the devices, TCP is implemented. Same protocol. So if same protocol is there, the protocol already has that, okay, which algorithm it will be using to calculate the checksum. How it will be calculating the checksum. This is clear? Yes or no? And how does encryption works? How does your encryption works? Simplest encryption if you want to see. Let's consider. Which? About what?
Some changing from source to destination. We change it. So hacker knows that which algorithm.
So why hacker needs to know? This is the case when your data is traveling in the clear text. This is the case when your data is traveling without any security. That is what we're talking about, right? That here we have integrity issue. Here we are facing integrity issue. So that is the reason that we want security. Otherwise, hackers will intercept. Another example, let me give you. Let's say, for example, your government has banned some applications. Okay. Let's say, for example, popular example, TikTok you can take, right? Now, if you directly try to use TikTok from your mobile data or from your ISP, you will not be able to access it. Now, why it is blocked? How your ISP come to know that you are visiting TikTok? How your ISP will come to know that you are visiting TikTok? Because they are able to look into your traffic. Now what? You open a VPN application, you will click on some other country name, and suddenly you start accessing. How does it work? That application is having some sort of magic that, okay, you'll click on the name and everything is now you're accessible. Everything is accessible. So how does it happen? Any idea? Why? You still get connected to the same Wi-Fi only. IP address is the country identification data. Top level domain. How? No. See, most of the VPNs that you're using are kind of a proxy. Now, I believe all of you know that what is a proxy. What is a proxy? On behalf of somebody else giving attendance to the professor, right? Okay. So understand here. Normally, what will happen in normal scenarios? Let's say this is my PC and this is internet. And some people will say that, okay, what your VPN will do, VPN will change your IP address. Correct? Let's see how the IP address really gets changed. And remember, it's not your IP address that is getting changed. It is just what you see. And why you see? Let's discuss. This is internet. Okay, consider this is TikTok server. Okay. This is, let's say, your PC. Okay. And this is your ISP. Now what? Let's say you are trying to access what? TikTok. So what will happen? In your traffic, what will be the source? Source will be your PC. What will be the destination? TikTok. Okay. This is clear. Your ISP will look where you are trying to go. Now this is banned by your government, not allowed. So what your ISP will do? Drop this traffic. This traffic is not allowed. Now what you'll do, you will use some sort of magical application. That is your VPN, right? You'll connect to VPN. In the VPN, you will see different types of country names. So those VPN providers, what they are doing is basically they are having different servers in different countries. Okay. So what will happen? Let's say this is one of their server. Definitely they are connected. The VPN provider will not put a VPN server at your home. Right. So let's say this is available in Singapore. Okay. So now what will happen? As soon as you connect to the VPN, a proxy has been set in your device. The application is acting kind of a proxy. Now, whatever your web traffic is there. So what you will do? You will say from here that, okay, sources, you are trying to visit what? TikTok again. But this time what will happen? Your source will be your PC. Destination will be Singapore. Okay. And in here, the real destination will be it. Now what will happen? Your ISP will see this. So ISP will see what information? This information. That what is the destination? Singapore. Your government is not blocking it. So what will happen? You will go from here to here.
I used to also see that.
No. This is the use of VPN, right? Tunnel. Okay. That means whatever is there inside the packet, encrypted. Yeah, the actual information is encrypted. And since this information, inside information is encrypted, your ISP is not able to see it. ISP will see that you're going to the destination, Singapore. So you will go here, your traffic will get decrypted here. Now, on behalf of your system, new message will be generated here. This time, source will be Singapore. And destination will be TikTok. This will be your destination. Okay. So this will go to the ISP. Now Singapore government hasn't blocked. So what will happen? Your traffic will arrive at TikTok server. Now, when TikTok server will receive this traffic, according to TikTok server, from where the traffic came? From Singapore. So it will respond according to the Singapore only. That means in the response, what you will see? Singapore, right? Source will be TikTok, destination will be Singapore. So the response message will come back where? Singapore. And from Singapore, the response will come back to. And this is actually what happens. That, when you check your IP address after connecting VPN. So to the destination, let's say this is the website. What is my IP address? Now on this website, the traffic is going from where? From the Singapore. So that's why this website is showing Singapore IP. It is not your IP getting changed. It's not your IP getting changed. You're just seeing because this website is receiving the traffic from where? Singapore. Is it clear? This is how it happens. And since this communication is encrypted, because here what will happen? Kind of a private network will be established. A tunnel will be established here. Okay. And your entire data will pass through this tunnel only. And that is the reason that your ISP will not be able to see it. Your data will travel through this tunnel. This is clear. This is how your VPN that you use in your day-to-day life works. Is it clear? Okay. Which type of? This you can call it IPsec SSL. Okay. Types will come to it. Okay, different types. One of the very common VPN. Okay, I might ask you that you are using VPN or not. Some of you might say that okay, we are not using VPNs, but you are actually using it. Where? Not many types. Almost every browser. See here. What is this? HTTPS. HTTPS. So what is this S? How does it secure? But how? How the connection is secure? No one will comment them. See here. What it says? No, not cookies. Read here what is it. How your connection is secure. That means your traffic is getting encrypted. Okay, one of the very common example, let me show you of this thing. How many of you have used Wireshark? Almost everybody have used? No? Used? See here. Now, what I'll do is, here this is so many UDP packets because of Zoom. From here, let's say I will visit a website. First of all, this is one website that is based on HTTP. Okay. So I'll go and capture HTTP traffic first. This is all the HTTP traffic, okay, that is getting generated right now. Now what? Here I'll try to go and log in. I have a login page. Let's call it VPN admin. I was able to log in. I didn't give any password. Okay. Now see here. If I see here, I have this post message. Okay. If I click on it, now focus here. In this message, I have something called as this HTML form URL, right? I'll expand it. Do you see what I see here? That means I was able to capture. Even if I had typed the password also, I would capture password also. This is HTTP, that is clear text. Now, let me try something else. Okay. So let me show. Now, HTTPS here you cannot capture. Why you cannot capture? Because it's encrypted. So it will come under TCP. Okay. So much of TCP traffic is there, right? There is so much of TCP traffic going on also. So let me go and access one website here. So that's cisco.com. Which is more secure, VPN or MPLS? Even on MPLS, you can configure a VPN, right? Both are secure. And VPN is almost used by almost every single organization. Now I have visited here and let me try to log in Cisco. I'll just use any random name. Maybe I have some, no. Okay, let's say XYZ at this thing I'm using. Any random username and password I'm using. Definitely I'll not be able to log in. Okay, let's see if we were able to capture this traffic. Okay, so traffic is any data you can take. Let's say this is coming from port number 443. TCP port number 443 means HTTPS only, right? So you click here, or this is the application data, and you see here what I get. Transport layer security, TLS. Okay, version is 1.3, and my entire application data is encrypted. I will not be able to. So this is kind of creating a tunnel. Okay, so this VPN that you're using in your day-to-day life, right? This is known as client-less VPN. Okay, and here also everything, your confidentiality, your integrity, everything is there. How? You can check that also, like which encryption algorithm is being used, which hashing algorithm is being used. Let's go here, connection secure, more information. And if you see here, okay, see here, my connection is encrypted. Which algorithm I'm using for encryption? AES 256. Okay. Hashing algorithm, SHA 384. Okay. My key size is 256 bit, and the current protocol I'm using for encryption is TLS 1.3. Okay. And if you want even more information, you can go and click on view certificate, and this will show you that, see here, the public key is created by RSA. Okay. And the key size is 2048. This is the modulus. Okay. Then these are the SHA-256 fingerprints. So this is how they are. You don't know? In SSH, crypto key generate RSA, general keys, modulus, right? So your SSH works basically on two large prime number concept. Okay, they will calculate two large prime numbers and they will then run some algorithm, mathematical algorithm is there. How encryption decryption key used? No, here encryption decryption key is not used. Here we are authenticating with the help of certificates. Okay, public key infrastructure. Here the communication, this is getting confirmed with the help of public key infrastructure. So here we are having certificates. Okay, so like public key certificate and private key. So whenever Cisco is sending something, I am already having Cisco's public key. Why? Because Cisco is having a certificate from a certification authority that is trusted. And if you want to see what is the certification authority, go to more information. Okay, view certificate and see here. Okay, so these are into the trusted list. These days, your browsers, they are already coming up equipped with certificates. See here. If you go to view certificates, here, these are the certification authorities your browser already trusts. So that means any website you're visiting, if they are having a certificate from these trusted entities, then it will show that, okay, the connection is secure. And if the certificate is not from these trusted authorities, your browser will give you the red symbol that it is not trusted. That means your connection is not secure. Okay, those kind of errors it will give here. So these are all the trusted authorities. So we use public key mentioned on the certificate and send it private keys with the Cisco to decrypt. Yes. Okay. So we are already having these all public keys. Now what, whenever I'm visiting Cisco, so my entire traffic will be encrypted with the help of this public key. And only Cisco has the correct private key. Only they will be able to decrypt. See, if we talk about encryption, your encryption is of two types. Okay. If we talk about your encryption, it's of two types. One is symmetric and second is asymmetric. Now, what is the difference between symmetric and asymmetric? No idea. In symmetric, what will happen? Same key will be used for encryption as well as decryption. And your AES algorithm is a symmetric algorithm. Okay. Asymmetric, here we have a pair of keys. Two keys will be there, public key and private key. Okay. So public key will be used for encryption while your private key will be used for decryption. Okay. So in symmetric encryption, we have a problem. We have a risk. What is the risk? That if somehow the key is compromised, somebody came to know about the key. So for encryption and decryption, same key is being used. That means anybody can decrypt the traffic now. That's why we have the asymmetric. In asymmetric, we have two keys. Okay. So your public key will only be used for encryption and your private key will only be used for decryption. You cannot use the same key for encryption as well as decryption. Okay, live example if you want to see. So let me show you. Okay. So right now you can see, we can try right now. This is what kind of encryption? This is the AES encryption. So let's say I want to encrypt the data with the name Cisco. Okay. So right now they are using their default key. Okay. So if I encrypt it, this is how my encrypted data will look like. And if I try to decrypt it, copy, paste. Try to decrypt, it is decrypted. So same key. Even I can show you the key also. Let's say, for example, I'm using the key as 123. I am deciding my key. Encrypt. Now this is the data that is encrypted with the help of which key? 1, 2, and 3. Now if I give this data and if I try any other key to decrypt, the data will not be decrypted. Why? Because the key is not correct. The key has to be correct. So for decryption also, I have to use the same key. What is the key? 1, 2, 3. Decrypt. This is clear. Okay. This is what your symmetric encryption is. Now let's talk about asymmetric encryption. That what is asymmetric encryption? So this is the RSA encryption and decryption. So first of all, what do you have to do in RSA? You have to generate keys. Without generating the keys, we cannot. So see here, different size of keys is there. Okay, so by default, it is selecting like 2048. If you want, you can go with the 4096 also. So two keys will be generated. One will be the public key and second one will be the private key. Okay, so if I generate, you will see these keys are also very large in length. And public key is relatively smaller than your private key. See the private key length. Okay. Now, if I want to encrypt any data, again, let's say I want to encrypt Cisco. Okay. And I'm using this public key right now. You can see here, this is the public key. And if I say encrypt, this is my encrypted data. Okay. So compared to symmetric, your encrypted data or your scrambled text or your ciphertext. Okay. The encrypted data is also known as ciphertext. So this is very large. Now copy it and let me try to decrypt it. So this time I'm already having here what? Correct private key. So if I have the correct private key, let me decrypt it. Do you see? Cisco. But in the same place, if I copy this, my public key only, and if I try to decrypt using the public key only, what will happen? Decrypt. Okay, you might say that here the key type I have selected private. Let me select public only. See, that doesn't work. Sir, during FTD classes, we have created certificates, that certificate, and this now. Yes, this is the same thing. Okay, Asma, this is the same thing. When we select 2048 bit, does it mean each character converted into 2? No, no, no. The entire, okay? The entire thing will be converted. See, now what will happen? That if I'm using the public key, I'm not able to decrypt it. What do I require? I require the private key only. Okay. So let's copy the private key from here. Copy. Paste. Now this is the private key. Private key. Decrypt. This is your data.
For every instance, the public key and private key will be there.
Yes. Okay. This is asymmetric encryption.
The next time it will change.
Which time?
Hmm.
It is up to you. You have to generate right keys. The keys you have to generate. So if you want to use the same, you can use the same. Okay. But it is not suggested that you use the same keys for a long time. You have to roll the keys or rotate the keys. Okay, that means you have to keep on changing the keys because
There is a software editing.
yeah. In VPN, what happens? See, you already decide that okay, what are the algorithms you are going to use. Okay, so since you have already decided what are the algorithms in SSH, how RSA keys are exchanged. So in RSA is just used to generate the keys. Okay, RSA is just an encryption algorithm. Key exchange and algorithm is different. Like in case of VPN, we will have DH, Diffie-Hellman. Okay, so that we'll discuss. That how the keys are exchanged and how the keys are exchanged securely. That part we will discuss. This is clear. Symmetric, asymmetric.
Before connecting VPN, it's going to be from offering.
During the see, when we will create the VPN, so when the tunnel negotiation will happen, so first of all, the keys will be generated and exchanged. So that time it will happen. Okay, once the keys are exchanged, now they are going to use the keys to encrypt the data. Okay. And there mostly AES algorithm will be used. Okay. You can use signatures also. This is about it. Okay. Now let's talk about the topics. So if we talk about types of VPN, right? According to organization perspective, we have two types. Okay. One is site-to-site VPN, and second one is remote access VPN. These are the two types. So these are the two types we will discuss, and we also have two categories, that is route-based VPN, and second one is policy-based VPN. Okay. So we'll discuss what is site-to-site, remote access, policy-based, and route-based. Now, first of all, let's discuss that what are the different types of VPN we are going to discuss. You will discuss, approx 20 or 22 different types of VPN. Okay, different scenarios, and multiple different comments will be there. So VPN from day one itself, not today, from tomorrow onwards, you will have to start your practice. If you do not practice, you will forget. Okay. So let's see the topics list. That okay, what are the topics we are going to discuss? Okay. So first of all, approx 1-2 days it will take in the theoretical part only, where we'll discuss, AES-3- these things. Okay. So tomorrow we'll discuss this part about cryptographic and hashing encryption. Although some of the part we have discussed today only, that how symmetric works, how asymmetric works. So this part we'll discuss today, and then we will start with PSEC. Okay. So see, your VPN tunnels you create to provide security to your VPN, we use these protocols, IPsec, SSL, or TLS. So this is going to take us around 3 to 4 sessions itself. Okay. Then after we will go with IKE version 1. Okay. So first of all, we will discuss that, okay, what are the protocols under IPsec? Okay. So those protocols we will discuss. So there you will come to know we have IKE, under IKE, we have IKE version 1 and version 2. So first of all, we'll talk about version 1 only. Okay. So we'll go with the site-to-site policy-based VPN between routers, between ASA and router, then between two ASAs. Okay. So like this we'll go, then we'll go on routing-based VPNs like GRE. First of all, simple GRE we'll see, then GRE with IPsec we will see. Okay. GRE with IPsec and SVTI we will see. Then after we will go with MGRE. Okay. That means multi-site GRE. This thing we will see, and after multi-site, we will go with the DMVPN. Okay. There we'll discuss about these three pages, page 1, page 2, page 3. Then we'll also cover about IPsec over DMVPN, dual hub configuration in the dual DMVPN. Then we will go with overlapping VPN. Now this is something that will create a bit of confusion. Okay, like what will happen here, that there are two different sites and their private networks are same. They are using the same network on the private. Okay, kind of the topology will look something like, let's say for example, this is your ISP. And then this side you have your edge device, consider a router. This side also, let's say you have your edge device. Okay, they are connected to the ISP. And then what you are using here, let's say for example, this is your internal network. Consider this is PC1. This is PC2. Consider R1, R2. And this is your ISP. Okay, so let's say you have 1110/24, 12.110/24. This side I have 10.110/24. This side also they are using 10.110/24. So here IP address 10.111. Here IP address 10.111. Here it is 10. Here also. Now you have to ping from PC1 to PC2. So this is known as overlapping because these subnets are what? Same. So if I try to ping from here 10.111 to 10.111 only, what will happen? This will be self-ping. The PC will never send out a packet to the router. That means if PC will not send out the packet to the router, there will be no tunnel setup. If no tunnel setup, no communication. Right? So this kind of setup will be there. This is known as overlapping. Okay. So this we will discuss. So here instead of routers, I'll be using what? ASA, where we'll be configuring manual NAT. We'll see about overloading, translation, NAT-T. Okay, this NAT-T concept we will cover it along with the IC version 1 only. Then we'll see about GATT VPN. Okay, that what is this GATT VPN? This will be used only in Cisco devices. This is not used in other vendors. Then we'll see VRF Lite. So I believe all of you are already aware of VRF and VRF Lite. NP you have studied. See, if you want to master VPN, you have to brush up your CCNP. You will have to brush up your CCNP. VRF, these all concepts will be required. Okay. VRF will be required. Your EIGRP configurations will be required. So these things will be required. So your routing, advanced routing will be required. Okay. Then here we will be completing your IC version 1 part. Okay. Once this will be done, then after we'll come to IC version 2. So approximately this will take us around, 14 to 15 sessions. Your VPN will take us around, 25 sessions, 25, 30 sessions. That much amount of time. That means 5 to 6 weeks of time it will take. Okay. Then IC version 2, we will see message exchange, then between firewalls, between routers, Flax VPN we will see. Okay. With the DVTI, VTI, and SVTI. Then we will come to the SSL VPN. Okay, so SSL VPN clientless, we will configure it on the router and ASA, full client, and then CA based site-to-site VPN. Then finally, we will have your L2P. Okay. So these are the 16 points I have mentioned. But here again, like I said, we will be working with different scenarios. So for different scenario, different lab, it will be like 20, 22 VPNs in total that we will be configuring. Okay. And if you will keep on practicing with like on time, and if you will be completing all the tasks, then VPN related questions in the interviews you can easily answer. Okay. These two you will be able to, I mean, VPN related questions you will be easily able to answer. Not completed. Let's see, two things are important in the VPN. One is your ASA. Okay. Your ASA concept should be clear. And second thing, your advanced routing concept should be clear. Okay. FTD is completed, but no. Because see what happens that here, let's say when we are using ASA, we will have a different configuration. Okay, VPN configuration will be different on ASA. VPN configuration will be different on router. VPN configuration will be different for VRF. So these concepts must be clear. Without these concepts, there will be problem. Okay. Yeah, L2TP layer 2 tunneling protocol. Like I said, EIGRP we will be highly using here. In the EIGRP also advanced EIGRP will be required, not basic one. Like you will say that, okay, router EIGRP 10 and done. Right? So that's why. At least some of the concepts you will have to brush up. Although I will be covering the things here, but I cannot explain same in depth here. Otherwise, RVP. At least VRF you should study and EIGRP in depth. In your, if you study advanced routing, right, these all IKE version 1, then DMVPN, GRE, these things are already there. If you had done your advanced routing, in that case, this would become very easy for you. Okay. So ASA also especially required here. Yes, ASA required. ASA will be required. Like I said, so many concepts are there where we'll be configuring the VPN on ASA also. Okay. Here we will require, then in the overlapping VPN, we are going to require it. In the IKE version 1 site-to-site between ASA and router, between two ASAs. So different concepts will require ASA also. This is clear. So I'll do one thing. A day before only, I will tell you guys that tomorrow you have to come up with this thing so that you can already check it out. And next day when I'll explain, it will become easy. Understood? ASA will take 5 weeks, 4 to 5 weeks. See, in your CCI security, we have large modules. What are they? VPN, FTD, ASA, and one more is there. ICE. These are the large modules. This will take like 5 weeks, 6 weeks, approx 2 months of time they will take this. Okay. So these are all the topics that we are going to discuss. Now let me do one thing. I'll be sharing. Today we'll not discuss anything technical about it. This encryption and introduction we have done and basics we have seen. Tomorrow onwards, we will start the theory of your cryptography. And then if we have time, we'll go with the IPsec also. We'll start. Okay.
No,
they are not different concept, but here they will not be required. About? No, here you don't require. So no, these concepts will remain same. Okay, these will remain same. So let me share the form link with you people. For online people, I'm sharing it in the chat.